Okay, we start off with some nice easy things to remember from Algebra 1. What does it mean to evaluate a function? Okay, to evaluate means take your given x value, right? Anything in parentheses is an x value, and plug it into your equation. So if we're going to evaluate f of 5, that means we do 2 times 5 minus 3. We replace x with whatever is in parentheses, and then we do the math. 2 times 5 is 10. 10 minus 3 is 7. Okay, so technically we're finding the y value from our f function when x equals 5. So we have the coordinate 5, 7 if we were going to plot that onto a grid. Okay, this one says plug in what? Says plug in C. So if we're plugging in a letter, that means we're going to have an equation as your answer. There's nothing to do. We are multiplying 2 times whatever C is and then minusing 3. The next one says plug in 4a into our same equation. So 2 times 4a minus 3. 2 times 4 is 8. So 8a minus 3 is our answer, right? If we have a letter to begin with, then we have a letter in our final answer. And this one says plug in the equation 5x minus 1. So we're going to put the whole entire equation into our function. So this is 2 times 5x minus 1 minus 3. And this is more like what we're going to be doing today with our compositions. We are replacing a letter with an entire equation sometimes when we're doing a composition. Okay, which is exactly what this next little blurb says. Sometimes in math, we plug a value for x into a function and use that output to plug into another function. Okay, when we do that, that's called a composite function. It is composed of 2 or more separate things. Okay, so let's do this one. This one is a pretty good problem. Okay, this is an AP style problem. We're given a function for g called 3x plus 1. And then whatever g of 2 is, we're going to call that c, right? Some other letter. And then we're going to figure out what g of c is. Okay, this is the most confusing way of writing this kind of stuff. So let's just do it one part at a time. Let's first find g of 2, which means replace x with 2, right? So we replace x with 2. 3 times 2 is 6. 6 plus 1 is 7. Okay? So we're calling this now C. I have named my answer C. So when I want to evaluate g of c, what am I really evaluating? G of 7. I'm really evaluating g of 7 because I'm calling c 7. So g of 7 is 3 times 7 plus 1, which is 22. Okay, so that's really how a composition is done. You find the y value of some given x, in this case an x value of 2, and then you plug that back into something else. In this case, back into the same g. Okay, so that's how we do compositions. We find a y value and plug it in somewhere else. Okay, so there's 2 ways that we can write composite functions. And you're going to have to recognize this notation, right? This is a symbolic notation for composite functions. Like a plus is a symbolic notation for addition, and the division sign, the vinculum, is the division one, right? The roots, we have all these symbols where there are 2 ways that we can write composite functions. One is parenthetically, using parentheses, in other words. So this says we have the f function and we are evaluating for the g function. So this is f with parentheses, and then g of x. Okay, so that's one way that you can represent a composite function. And the other way is with this tiny little symbol. Okay, it's not an O, and it's not a multiply, but it's a composition. So this is the symbol. This is the symbol for composition. Okay, so when you write it, make sure you write it small so it doesn't look like the word fog or goth or anything, that you know it's composition. Okay, and it's read f of g of x. Okay, so this first of represents the composition, right? The second of represents your parentheses. Okay, when working with a composite function, you start off on the inside. So whatever's in parentheses. So in other words, in this case, we're going to evaluate your g function first. Okay, whatever g of is, you do that first. And then you use the answer from g and plug it into f. Okay? So we evaluate the g function first, and then we use that answer to give us a second answer, and potentially a third answer if we are so inclined. Okay, so let's do some of these. Here we have two functions. We're calling the first one f and the second one g. And we want to evaluate f of g of 2. So first we evaluate g of 2. Okay, so what is g of 2? That means we're plugging 2 into our g function, right? We're replacing x with 2. So 2 times 2 is 4. 4 plus 1 is 5. So g of 2 is 5. So I'm really figuring out what is f of 5. Right? That's going to give me my final answer. So f of 5 is what I get when I plug 5 into my f function. So 3 times 5 minus 5, right? This is my f function. 15 minus 5 is 10. So my final answer is 10. G of f of 3. So first we're going to do f of 3. Okay, so let's evaluate f of 3. That's 3 times 3 minus 5. 9 minus 5 is 4. So we're really evaluating what is g at 4. Okay, so instead of x, we're going to plug in 4. And of course, 2 times 4 is 8. 8 plus 1 is 9. So our final answer is 9. Okay, our last example, f of 4 means we evaluate using the f function, and then you plug that back into the f function. Okay, let's see our next stuff. Okay, using equations from example 2, let's do this. So this one says take the g equation, take 2x plus 1, and plug that equation into f. Okay, so f says do 3 times something minus 5, right? That's what our f function says to do. Whatever you give me, I'm going to multiply it by 3 and then subtract 5 from it. So in this case, I am given 2x plus 1 because that's what my g function is. My g is 2x plus 1. So I simply have to simplify this, right? I distribute 6x plus 3 minus 5 simplifies to 6x minus 2. So let's look at the other one, do the other way. Now it says take my g function, which is multiplying something times 2 and adding 1. And that something that I'm going to put in is now a 3x minus 5. So this is more like the ways we see composition is with an equation, right? We're replacing x with an equation and simplifying it as much as possible. Okay, this is the back of the worksheet. Now I have 4 different functions, h and k and p and m. So it says evaluate h of 2 or k of h of 2. So first I'm going to plug 2 into my h equation. Okay, so h of 2 is 4 minus 3, which is 1. So I'm really looking for what is k of 1. So here's my k equation. So 1 squared plus 4 times 1 plus 5 is 10. Right, because this is 1 plus 4 plus 5. 1 plus 4 plus 5 is 10. So that's pretty standard. Now we have it in, oh, look at this notation. This is with our composition notation. When we have it like this, we want to evaluate the closest thing first. So we're going to evaluate what is m of negative 1. Okay, m of negative 1. So we got to come over here. There's my m equation. M is 3 times x plus 2. Okay, which is, of course, negative 3 plus 2, which is negative 1. M of negative 1 is negative 1. So now I'm going to evaluate that in for my h. I missed. Okay, so when you have it in a composition format, you evaluate the closest letter first. The closest letter first. So h of negative 1 is 2 times negative 1 minus 3, which is negative 5. So part C says k of p of x, which means we're taking our p of x equation and plugging it into k. So my p of x equation is a square root equation, and k is a quadratic. So how many x's do we see? 2 x's, which means I have to replace it twice. So first I'm squaring it, and then I'm multiplying it by 4. Then I'm adding 5 to whatever that answer happens to be. So root 3x plus 1, root 3x plus 1. Everywhere I see an x, I replace it with that equation. So let's do some evaluating. What happens when I square a square root? Right? These ones essentially undo each other. So this is just normal 3x plus 1. What happens when I multiply a root by a number? Nothing. So 4 times the square root of 3x plus 1. Nothing happens. They just stayed multiplied together. And then I have my plus 5. So what can I combine? I have a plus 1 and a plus 5. So 3x plus 6 plus this random radical product. Okay, so not everything can simplify all the time, but that is the correct answer nonetheless. Okay, let's get to the good stuff. Here we have your big 4. Okay, big 4. So we are representing something as a graph. Here we have represented as a table. This is represented as an equation, right? A piecewise function. And here we have it represented as words. Right? These are the 4 ways that we can represent information in math, right? Especially here in pre-calculus. So first, let's do the words. Let's change our words into an equation. K is a quadratic function, which means it's going to be a squared. Something is squared, x is being squared, with a horizontal translation of 2 and a vertical translation of minus 3, which means it's being moved 2 units to the right. So how do we represent a 2-unit translation to the right for a quadratic? With parentheses, right? Any type of a horizontal translation gets parentheses. And if it was moved right, that means I have a minus in parentheses. So x minus 2 is squared because it's a quadratic. And then my vertical translation is a minus 3. Okay, so it's important to be able to take our words and write them down as an equation, because equations are usually much easier to evaluate than words are. Okay, let's use our 4 things to do all of these compositions. Okay, g of 3. Do we have a g of 3? No, we don't. Okay, so that's not good. Let's change it to a g of 2 and see what happens, and see if that makes any more sense. Okay, g of 2. So we come to our table. When x is 2, our y value is 3. Okay, so I'm evaluating g of 2. That is the number 3. And now I have to find from f, what is the y value from my graph when x is 3? So there's x is 3. That means my y value is at 1. Right? Because that's the y value from my graph when x is 3. Okay, if we ever have one of these, right, then it's undefined. So f of 5 is undefined. F of 2, well, that's 1, because that's where our closed dot is. Right, f of 6, that's 3, that's where our closed dot is. Right, there's no 6.5, there's no 5.5. We can only evaluate for the ones we have points for. Okay, h of f of 8. So first we do f of 8. So we go to our f graph. When x is 8, our y value is -1. So then what is h of -1? So let's go to our h. Oh, h is a piecewise equation with 3 categories. So we have everything less than -1. We have if x equals -1, and then we have values greater than 1. So where does -1 fall? Is it the top, the middle, or the bottom? We're going to use the top equation to evaluate -1 because -1 is less than +1. So we're going to use the top equation, which says take the absolute value of -7 plus 3 times our x value. And in this case, your x value is -1. Okay, so -7, -1 times 3 is -3. -7 plus -3 is -10. The absolute value of -10 is +10. Okay, absolute value makes things positive. Okay, part C, doing some more. What is k of 0? So k of x means we're plugging in 0 for x right here. 0 minus 2 squared minus 3. So 0 minus 2, that's -2. -2 squared is +4. 4 minus 3 is 1. So we're really looking for what is g of 1. Okay, so where's my g? There's g. Do I have g of 1? I don't have a g of 1. There's no 1 value, so g of 1 is going to be undefined, right? I do not have an x value of 1 in my g table, so g of 1 is undefined. G of 1 is undefined. There is no y value from our g function when x is 1. We only have those 5 particular points. Okay, f of 2. F of 2 is 1, right? F of 2 is 1. That's the y value. And f of 1 is, up here, f of 1 is 4. Okay, so our answers are always y values. H of 1. Didn't we say that's undefined? H of 1 is undefined. Do we have a g of undefined? No, h of 1 is not undefined. H of 1 is defined. That's g of 1 that's undefined. Okay, h of 1. H of 1 is what value? When x is 1, h is minus 4. So h of 1 is negative 4. G of negative 4 is pi. Right? G of negative 4 is pi. 3.14159.265. Oh man, look at F. That has a lot. But we start at 0. We start here. Okay, we start there and then we're going to finish all the way down to 1. So make sure you're doing it one thing at a time, evaluating until you have got your numbers down. Okay, so compositions, you're getting an answer and you're plugging that in somewhere else to get a second final answer.